DragGAN is a new AI tool that lets you edit images by simply dragging elements around with your mouse. For example, you can make a subject smile in a photo, change the pose of your pet dog or cat, edit clothes in photos, drag mountains to be higher, and much more. The only real limit is your imagination. Here it is in action. The secret behind how Drag Your GAN works its magic is a type of machine learning algorithm known as a generative adversarial network, or GAN. GANs use neural networks that are pitted against each other to create new examples from a set of training data, like images, music, speech, and more. The researchers that developed Drag Your GAN leveraged GANs to build a generative image manifold. A generative image manifold is like a latent space that contains all the ways an image can be deformed and manipulated while still looking natural. You can think of it as a multidimensional surface that encodes how all the pixels in an image are related to each other. An analogy would be to imagine a ball of clay. The clay represents a single image, and all the different ways you can squish, stretch, and mold the clay represent different deformations of that image. The clay ball retains information about how its shape comes together to form a whole, so when you make a change to one part, the rest of the shape updates automatically. In Drag Your GAN, the generative image manifold works similarly. It learns how all the pixels of an image are interconnected from a set of training data. Then, when you grab and drag a point on your screen, the generative image manifold determines how to manipulate the image by pulling on it in that spot, while keeping the rest of the image coherent. For example, the manifold may learn that when you drag on a spot near the mouth in a human portrait, it should produce changes to facial expression, but not alter the hair or eyes. Or if you drag on the roofline of a car image, it may tilt just that section and leave the rest of the car unchanged. The generative image manifold has developed an understanding of what kinds of deformations make sense for different categories of images. Another analogy is to think of the generative image manifold like a map. When you click and drag a location on the map, the roads and landmarks near to it will move accordingly, while those farther away are relatively unaltered. The map as a whole is cohesive even after your edits. The generative image manifold similarly keeps the map of the image cohesive when you make changes to a local region by dragging a point. By encoding how pixels relate across an image, DragGAN enables both local changes and global coherence, turning images into a form of clay that can be sculpted at will. You can check out more DragGAN demos and the official paper in the link provided in the description. I hope this helps provide an intuitive sense of how a generative image manifold works.